I hope you had an awesome spring break. I'm back with more math for you today. So grab your pencil and your book and we'll get started. All right, so today's daily math is patterning and algebra. So it says to write the first 3 numbers for this pattern rule. So we have to read the rule and figure out the pattern that way. So it says start at 245 and add 11. So this is going to be, because it's adding, it's an increasing pattern. I'm going to say that really slow again. Increasing pattern. Okay, I don't know why I slowed it down, slow motion, but increasing pattern, we're going to start at 245, so that's going to be our first number, 245, and then to get our next number, we add 11, so count by 10 and then add one more, 245, 255, 256, 256. Okay, and now we have to add 11 again. So this was plus 11. Now we have to add 11 again. 256, count 10, count one more. 266, one more, 267. 267. Okay, on to the next one. Add 11. Okay, we have to write the first 3 numbers. I'm going to do a couple more because I love illustrating patterns. So again, 245 plus 256 plus 11, 267 plus 11 again. So let's count a 10 and a 1, 267, 277, one more, 278. And just because I love math so much, we're going to do one more. So you can see how easy this is. Patterns are nothing to be freaked out about. So again, I'm going to add 11 more, 278. So you add 10 and one more, 278, 288, 289. 289. Okay, so it's just starting at 245 and adding 11 each time. So you count up 10 and one more. Okay, what is the following pattern rule? Okay, so let's look. 100, 200, 300, 400, 500. So I know it is increasing. It's an increasing. And I know it starts at 100. So start at 100. Increase by how much each time? It's going up by how many? 100, 200, 300, 400, 500. It's increasing by 100. Okay, my next one, 66 plus something is 91. So this is a little bit of algebra to start your morning off right. So I know that I have 91. I know that both sides of this equation need to be balanced. Right, I need to have the same number. I'm just going to cover this up, guys, because I find it's distracting me, and I can only imagine it's distracting you. So, there we go. That's better. So, 66 plus 9 something is 91. So to find that out, we just have to do the opposite. What do you mean, Mrs. Oakes? Well, do 91. Subtract 66. Find the difference between these two numbers, and that's going to tell you how many you have to add to 66 to get to 91, because addition and subtraction are inverse operations. They're opposite operations. So I am going to do Grandpa's way for this adding. If you are one of those people who likes to use a different strategy or you want to count up, that's awesome. I just find sometimes it's nice to model Grandpa's way, because sometimes people, that's the one that they're most comfortable with. So 1 subtract 6, I can't do it, so I need to borrow from a neighbor. So I'm going to go next door to the tens and say, can I borrow a 10? Sure. Now there's 8 tens, but there's 11 ones. So I have 11 ones. 11 subtract 6. So I know 12 subtract 6 is 6. So 11 subtract 6 is going to be 5. 8 subtract 6 is going to be 2. 25. Now, if you wanted to check that, you could just add them, stack them up. 66 plus 25 Let's add them together. If we've done this correctly, it should equal 91. 6 plus 5 is 11. 6 plus 2 is 8 tenths, or 60 plus 20 is 80, 8 tenths, and 1 more is 9 tenths, 90. So yeah, it works. 66 plus 25 is 91, and I found that out by using the inverse operation, doing the opposite to figure out what I needed to know. Okay, number 4 is, so we're going to look at this pattern, not poem, pattern, and we're going to find out if it's growing, shrinking, or repeating. So is it increasing, decreasing, or repeating pattern? Growing, shrinking, or repeating? So let's get looking at it. So I'm going to read it, and you'll probably know right away. 100, 90, 80, 70, 60, 50. Well, my numbers are shrinking. It is a shrinking pattern. Okay, my numbers are decreasing. Now it's asking you to extend the pattern. Extend the pattern. So we have to figure out what this pattern is before we can extend it. And when I see it, I was like, I don't know. Maybe you're freaking out. But don't freak out, because we can do this together. Sometimes patterns seem confusing, but when you look closely at them, they're not. So how many this is, first of all, look at it, 80, 91, 102, and 113. So we know it's increasing. It is an increasing pattern. Okay, it's an increasing pattern. So we know it's getting bigger. How much are we getting bigger by each time? What number are we adding to each time to extend the pattern? What is the rule? So I know 80 plus 91, well, that's plus 11. Okay, so let's make sure that this works for the next one. 91 plus 102. Okay, 91, 101 plus 1 more. Oh, this is also plus 11. 102 plus 113, also plus 11. So I figured out my rule is increase by adding 11 each time. So 80 add 11 is 91, 91 add 11 is 102, 102 plus 11 is 113. Let's count on 113 plus 11, so plus 10 and then add 1 more. 123, 124. 1, 2, 4. Now let's add 11. 124, 134, 1 more, 135 plus 11. So add 10 and then add 1 more, 135, 145, 146. All right, now we're going to move on to a problem. You know how I love solving problems. So let's read it, find out what they're adding or what they're asking, and then I'll show you my awesome picture to solve it. Okay, so Sally bakes a pie and cuts it into 8 equal pieces. Her brother eats 2 pieces and she eats 1 piece. What fraction of the pie is left? So Sally is very nice. She bakes a pie, and I'm going to underline, or actually I'm going to highlight what's important. So she's baked a pie. She's cut it into 8 equal pieces. So she's cut it into 8ths. Her brother eats 2 pieces, and she eats 1 piece. What fraction of the pie is left? So let's draw it out. We've got all our information here. We know it's going to be a pie with 8 pieces. Her brother eats 2, she eats 1, and we're trying to find out how many pieces are left. So I have drawn Sally's tasty pie, and if you look down here, here's Sally and her brother. They're saying, yum, pie. We're going to break this pie into, or we're going to cut it into 8 equal pieces. So 8 equal pieces. Sorry, I just had to pause my video to let my friend outside. Now, Rue is outside, so we're good. We're going to take Sally's tasty pie, and we're going to break it into, now remember from our question, 8 equal pieces. Okay, so Sally's tasty pie, I'm going to break it into 8 equal pieces. So I'm going to start with 1. Now I have 2 pieces, and I'm doing my best to make them equal. We're going to pretend they're perfect. 1, 2, 3, 4 pieces. Now, if I break each of these 4 pieces into 2 pieces, I should have 8, right? So let's try. So Sally cut up her pie. There's Sally's tasty pie. Okay, and she has cut it into 1, 2, 3, 4, 5, 6, 7, 8 pieces. Now, Sally and her brother eat some of this pie before we can figure out how many pieces are left. So they eat 2 pieces, her brother eats 2, and she eats 1. So altogether, 2 plus 1, they eat 3 pieces. So they eat 1, 2, 3 pieces. Now how many pieces are left? 1, 2, 3, 4, 5. So we had 8 pieces in total. And we have 1, 2, 3, 4, 5 pieces left. I'm going to do a little bit of math with you guys here. Don't panic. I'm going to show you what this looks like using an equation, using writing out the fractions. Okay, so I'm going to show you what this looks like using an equation. This is just extra math. So I had, we had 8 out of 8 pieces total. And we subtracted 1, 2, 3 out of 8 pieces, okay, because they ate 3. And our total left, so 8 subtract 3 is 5. The bottom number doesn't change, guys. It stays the same. So there we go. We had 8/8, that's our whole. We subtracted 3/8, and we got 5/8. So you saw that with the picture. This is just how you would write it out with numbers. So again, it's the same. Here's 8/8 all together. We subtracted, they ate these 3 pieces, and then we had 1, 2, 3, 4, 5 pieces left, 5/8. So going back to our problem, Sally bakes a pie and cuts it into 8 equal pieces. Her brother eats 2, and she eats 1. What fraction of the pie is left? 5/8. I wonder who she might share that with. Okay, we are going to switch to the other camera angle to do our multiplication on the whiteboard. So let's do that. Make sure you're ready for your multiplication. Let's start working through these multiplications questions. So remember, you can use whatever strategy you like. Box window, grandpa's way, or your own personal strategy. Today I'm going to model partial products, but that does not mean that's what you need to use. As long as you're getting the same product at the end, the same total, then you know you're on the right track. If not, go back and check your math, okay? So to do partial products, just imagine that I am first doing 5 times 93. That's what I'm starting with, okay? So you can see my dotted line. We're going to do 5 times 93 to start. Ignore the 10 for now. We'll get to that later. So 5 times 93. I start with 5 times 3. So 5 times 3 is 15. So I'm going to put my 5 here, and then I know I have a plus 10 up here. I'm just going to put plus 1 in my tens column. Plus 1, because I know I have to deal with that later. Now I go 5 times 90. 5 times 90. It's the same as 5 times 9, just add a 0. So 5 times 9 is 45, 450. Okay, so, and one more, 460. So 465. So 5 times 93 is 465. Now, my next one that I have to figure out is actually pretty easy because we know how to do this without going through any steps. So I can erase this because I've already taken care of that. So the next one I'm doing, I'm thinking of, right? 1 times 93. But it's not 1, it's 10 times 93. So I put my 0 there to make it 10 times. And then I just go 1 times 93. 93. 10 times 93 is 930. Okay, and now I'm going to add the 2 together. The two numbers 5 and 0, it's 5. 6 and 3 is 9. 4 and 9 is 13. So my answer is 1,395 for my first one. One is 88 times 21. As you can see, I'm going to be doing this one. I'm going to figure it out using box window because why not model a bunch of strategies? Okay, again, strategy isn't as important as the math. So I'm going to set this up. 88 times 21. So 80 and 8 times 20 and 1. So 2 times 8 is 16. 2 zeros. 0, 0. 20 times 8. Well, 8 times 2 is 16. 1, 0. Okay, my next one, 80 times 1 is 80, and 8 times 1 is 8. Now I have to add them all up, so I can stack them real quick. 1600, 1600, 160, 80, and 8. Zeros. Remember, they're in line, so that it's easy to add. 0, 0, 0, 0, 8. 6 plus 8 is 14. 6 and 1 is 7. 1 more is 8. And then I just have the 1. So 1,848. And I should line that up better with my 10s and my 1s. 1,848. Okay, so that's my second one. First one, I realized that I said partial products, but I was actually modeling more of Grandpa's way. So there's similar strategies. I'm going to go through partial products and break it down even more for the next one. And again, you can use your own strategy of choice, but I have 87, and I'm going to be timesing that by 15. So for partial products, again, I misspoke at the beginning, kind of, but it's all the same. You're going to go 5 times 7, 5 times 80. Okay, and then you're going to go to the next one. You're going to go 10 times 7, 10 times 80. So you're just, and then I'll have 4 different answers to that, and I'll add them all together. No, I dropped my pen. 7 times 5 is the first one. So 5 times 7 is 35. Then I go 5 times 80. So 5 times 8 is 40. To do 5 times 80, all I have to do, 5 times 80 is 40 with a 0, 400. Okay, now I'm on to my 10s. 10 times 7. 10 times 7 is 70. And then 10 times 80. 10 times 80, well, 1 times 8 is 8. 10 times 80. Remember, we look 10 times 80, 8 and 2 zeros. Okay, 800. Now I'm going to add these all together. 5, 7, 8, 9, 10. 5 and 8, so 8 and 5. Okay, 8, 9, 10, 11, 12, 13. 1,305. Again, you could use any strategy. This is partial products. The first one was actually Grandma and Grandpa's way, and the middle one I did box window. Whatever works for you, we should be all getting the same product. Okay, numerators and denominators. Now, back in the 90s, there were some movies called, I don't know if you've heard, the Terminators. So when I was in school, I'd never seen those movies, but every time a teacher brought up numerators and denominators, it sounded so ominous. It's not. It's nothing scary. Numerators and denominators are just the fancy math words we use to describe what these numbers are. So if you hear numerator, you know it's the number on top. If you hear denominator, you know it's the number on the bottom. They're fancy words to say something that you already know about. So numerator, the numerator is the number on top. It represents the parts that we have. So when I did my Sally explanation, right, just looking here, let's just find our numerators and denominators. So numerator, 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 denominator, denominator, denominator. Again, guys, top number, bottom number. Don't freak out over the words. It's just math words, but they're important to know and to practice. So we're going to practice those today. Numerator, denominator. I don't know why I'm saying them that way. Like I said, I'm a child of the 90s. Okay, so let's read this. The numerator is the top. We read that one. The denominator is the number on the bottom. It represents the total number of equal parts in the whole. So the numerator is the top number. The denominator is the bottom number. So let's go through to make this easy for you to see. I'm just going to write the fractions. So this should have a line there. It's 1 out of 3 are shaded. This one, 1, 2, 3, 4, 5, 6, 7. I have 7 on the bottom, and I have 1, 2, 3 out of 7 shaded. This is 1/3. 1 out of 3 are shaded. Again, numerator, denominator, numerator, denominator, numerator, denominator. Now I have 4 total, and I have 1, 2, 3 shaded. I have 3 total, and I have 2 shaded, and I have 1, 2, 3, 4, 5 total, and I have 1, 2, 3 shaded. So I wrote those out to help us with this question. It says shade all of the pictures that have 3 as their numerator. So we know the numerator is the top number. We just have to go through. I'm going to take my highlighter. This one has 3 as its top number, as its numerator. This one has 3 as its numerator. And this one has 3 as its numerator. All right. The rest, they do not. They don't get to be pretty and yellow. The next one, it says shade all of the pictures that have 4 as the denominator. So let's go and write this out. Remember, denominator is the bottom number. So I have 1, 2, 3, 4. This one will have 4 because my denominator goes on the bottom. And just for fun, I'm going to write the whole fraction. 1, 2, 3, 4. Oh, this one also has a denominator of 4. And the numerator is 3. 1, 2, 3, 4, 5, 6. My denominator, the bottom number is 6. And I have 1, 2, 3, 4 shaded. Okay. Next one. 1, 2, 3, 4, 5, 6. 6 is my denominator. And I have 1, 2 shaded. The next one here, I have 1, 2, 3, 4 as my denominator. And I have 2 shaded, so I have 2 as my numerator. What? Oh dear, this is hard to see. Let me just make sure I can read it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as my denominator, and I have 1, 2, 3, 4 shaded. So I have 4 as my numerator. Okay, and the question is asking, shade all the pictures that have 4 as the denominator. So the bottom number. Let's go. Oh, you couldn't see my awesome highlighting, but we're looking at the bottom number has to be 4. Denominator, bottom number. So bottom number is 4, 2 out of 4. Bottom number, numerator is 4, 3 out of 4, not 4. This is 6th. The denominator is 6. Ooh, this one's 4 as the denominator. This one has 4 as the top number, the numerator, but what is the question asking? The question is asking 4 as the denominator. Okay, on to the next one. It says, write the numerator and denominator for the fraction that is shaded. So, we're going to go through and make some fractions. Numerator and denominator. So, for the fraction is shaded. So, this one here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 as my bottom number as my denominator, and I have 1, 2, 3, 4, 5, 6 of them are shaded, so it's 6/9. Okay, this one I can't really see, but I'm going to try and make it equal parts here. So 1, 2, 3, 4, 5, 6. I have 6 as my as my denominator, and my numerator I have 1 shaded. 1/6. Now on to the next one. I have 1, 2, 3, 4, 5, 6 as my denominator. And my numerator, I have 1, 2, 3 shaded. So that's all it is, guys. It's very simple. Fractions are just a way of writing down things we're already doing. So 1, 2, 3, 4, 5, 6, 7, 8 is my denominator. And 1, 2, 3, 4, 5, 6, 7 is my numerator. Okay, I have 1, 2, 3 total pieces, so my denominator is 3. And then I only have 1 shaded, so my numerator is 1. Now this one I have 1, 2, 3 pieces, so my denominator is 3. And I have 1, 2 shaded. Okay, and I made sure I read my question because it is asking what fraction is shaded. I do recommend reading questions because sometimes it might say which fraction is not shaded. You never know. Okay, so this one's really hard to see, but these two are shaded, I believe. And I have 1, 2, 3, 4, 5, 6 pieces in total, so my denominator is going to be 6. And then I have 1, 2, 2 out of my 6 are shaded. Okay, next one. 1, 2, 3, 4. I have 4 pieces total out of my whole, so 4 is my denominator. And then I have 1, 2, 3 pieces. My numerator is 3. Okay, I really like fractions. I hope you enjoyed working through some fractions with me today. I hope you liked the fractions question that we had to draw out. I hope you're starting to understand the words that we're using. Again, these are words you've used in previous years, but numerator and denominator aren't things that often stick in our mind. So just remember, we're going to make them stick now. Your numerator is the number on top. Think of it as the number of pieces shaded. Your denominator is the number on the bottom, the total number of pieces. Okay? I hope that's clear. If not, check back tomorrow for more math because I will be explaining this all week. Have a great one. Join me for the math. It was lovely to work through that. I really hope that was helpful if you were stuck. If you know what you're doing and that was just a review, then at least now you know you've got it right. I hope you have a great rest of your day, and I'll see you back here tomorrow for more math.